Are you looking to build or buy a gaming PC in 2026, but you're not sure where to start? We've got you covered. Welcome back to PC Builder. I'm Jason. We're going to cover the critical components that make up a PC build in 2026 and how they work together. We'll take a look at the latest platforms from AMD, Intel, and NVIDIA. And I'll give you several different gaming PC build lists, starting at an $800 gaming PC build to mid-range 1440p gaming PC builds for between $1,000 and $1,400, and a high-end gaming PC build for right around $2,000. If you get value out of this video, please give it a like or subscribe for more cool PC content. Let's jump into it. So there's 8 critical components to a PC build in 2026. The computer processor, or CPU for short, the graphics card, or GPU for short, the motherboard that connects everything together, the RAM, the CPU cooler, the storage like an SSD drive, the power supply, and the PC case with fans for airflow. If you're building a gaming PC in 2026, the graphics card, or GPU for short, is the most important component to get right. The GPU is going to determine what resolution that you're able to play at, 1080p, 1440p, or 4K, and how many frames per second or FPS that you're going to get at that resolution. 60 FPS is a common FPS target for PC gamers at higher ultra settings in single-player titles like Kingdom Come Deliverance 2 or Elden Ring, and much higher FPS in multiplayer competitive titles like Battlefield 6, Arc Raiders, and CS2. Graphics cards are ranked both by how fast they are, how much FPS you're going to get, but also by the amount of video RAM or VRAM that they have. Now, running out of VRAM, that can cause stuttering or textures not to load, either making the game look muddy or crashing outright. This can force you to turn down the graphics settings on a game from ultra or high settings all the way down to medium or even low in order to get a playable experience, especially at higher resolutions like 1440p or 4K. Turning on ray tracing also uses more VRAM. In 2026, I recommend at least 16 gigabytes for no compromises 4K gaming or 1440p with high ray tracing, 12 gigabytes of VRAM for 1440p gaming, 10 gigabytes for 1080p, and anything less than that may need to turn down graphics settings even at 1080p on some games. Now, the graphics card itself plugs directly into the motherboard, and you use the video outputs on the back of the graphics card, not the motherboard. PC gamers will want to use the DisplayPort cable rather than HDMI cable for best results. We go through more of that in our Best Gaming Monitor 2026 video, which is linked down in the video description. Now, in 2026, graphics cards are made by NVIDIA, AMD, and Intel. The most commonly available graphics cards available brand new at retail right now include the RTX 50 series graphics cards and AMD's RX 9000 series graphics cards, along with the Intel B series graphics cards. At the ultra high end of graphics cards, we have the NVIDIA RTX 5090 with 32 gigabytes of VRAM. In the high end, we've got the RTX 5080 and 5070 Ti, along with AMD's RX 9070 XT, all of which have 16 gigabytes of VRAM. In the upper mid-range, we have the RX 9070 16GB and the RTX 5070 12GB. Moving down to more affordable 1440p graphics cards, we've got the RTX 5060 Ti 16GB and RX 9060 XT 16GB graphics cards. Now note that both of those GPUs also come in 8GB VRAM configurations. We've also got the Intel Arc B580 12GB. In the more budget range, we've got the RTX 5060 and RTX 5050, both with 8 gigabytes of VRAM, and we also have the Intel Arc B570 with 10 gigabytes of VRAM. There are also some older generation graphics cards that are still available, like Intel's Arc A750 and A580. Of course, while AMD, NVIDIA, and Intel make the GPU chips on each of these graphics cards, the rest of the card itself is manufactured by what are called add-in board partners, or AIBs for short. ASUS, MSI, Gigabyte, ASRock, PowerColor, and Sapphire are just some of the names that you might see on a graphics card box, and they will typically have a couple different models for each graphics card, and the differences are usually in terms of cooling, the size of the card itself, RGB lighting, and other aesthetics, and whether or not the card is factory overclocked for a little bit more performance. Note that NVIDIA does make a small amount of Founders Editions cards itself, and Intel similarly makes a small amount of reference cards, but the vast majority are made by their board partners. The good news is that all the GPUs I just named have good upscalers. NVIDIA has DLSS 4, AMD has FSR 4, and Intel's XeSS 3 is rolling out to its graphics cards. Driver support in 2026 is fairly good for all three. And if you want to stream your gameplay to a service like Twitch or YouTube Gaming, do video capture of your desktop or gameplay, or do video editing, then more good news. NVIDIA, AMD, and Intel GPUs are all very good at these workloads. All right, let's talk about central processing units, or CPU for short. There's two major CPU makers, that's AMD and Intel. Now, they make a variety of CPUs, but we're just going to focus on their consumer desktop CPUs today. But the CPU itself has more than one brain it can use at a time, called a core. Now, most modern processors have at least 4 cores, currently come in 6, 8, 10, 12, all the way up to 24 cores and possibly beyond in the near future. The more cores, the more a CPU can do at once, though some tasks like gaming only need between 4 and 8 cores, depending on how powerful the CPU is. Many AMD and Intel CPUs have cores that can do up to 2 tasks at the same time, something we call multi-threading. So when I say the AMD Ryzen 5 9600X has 6 cores and 12 threads, that means it has 6 cores that can each do roughly 2 things at the same time. Intel CPUs currently are a big little design, with big cores that they call performance cores and smaller cores which they call efficiency cores. So the Intel Core Ultra 5 245K has 6 performance cores and 8 efficiency cores for a total of 14 cores. Now, the most currently relevant AMD CPUs are the Ryzen 9000 and 7000 series CPUs for most mid-range and high-end builds, and the Ryzen 5000 series CPUs for budget gaming builds. The currently relevant Intel CPUs are the Core Ultra 200 series and their older 12th, 13th, and 14th gen CPUs. Now, currently, the fastest gaming CPU is the Ryzen 7 9850X3D, which has extra onboard memory called cache, stacked vertically on the CPU, hence the name 3D. AMD Ryzen CPUs are unlocked, meaning you can overclock them if you choose to, and you can also overclock the memory with them. Intel CPUs labeled with a K in the name can be overclocked, but only on compatible Z-series motherboards. More on that later. But none of the other Intel CPUs can be overclocked. Newer generation CPUs without an F in the name come with integrated graphics, like the Ryzen 7600X or Intel Core Ultra 5 245K. However, the integrated graphics, they're only really strong enough for desktop-related tasks. They're definitely not good enough for gaming. CPUs with an F in the name, like the Ryzen 7500F or Core Ultra 5 245KF, do not have integrated graphics. You can check out our monthly best CPU video where we go through the best CPU for gaming and creators for our current recommendations, but right now we are heavily leaning towards AMD CPUs until Intel launches its next generation. So what is the right CPU and GPU combo for you? Well, we've got a whole video dedicated to this topic based on every budget, and I'll link it down in the video description in our How to Build a PC 2026 video playlist. When building a gaming PC, you'll want to get the biggest, fastest GPU you can afford. Typically, this is around half of your overall budget. Then just get a CPU that's not going to bottleneck our GPU. For systems focused on professional creator or production work that can take advantage of a lot of CPU power, we'd probably want to scale our CPU up a little bit more, but it will vary depending on the programs that you're using. So check the recommended specs for your applications. All right, let's talk about the motherboard, because this is one area I see people overspend all the time. Now, the motherboard is the thing that all the components plug into and allows it to work together. While motherboards are made by manufacturers like ASUS, ASRock, Gigabyte, and MSI, they are made using what is called a chipset that is specific to either AMD or Intel. So you can't use an AMD CPU with an Intel chipset motherboard and vice versa. And each CPU will only work with a specific chipset. For Ryzen 9000 and 7000 series CPUs, you want an AMD 800 or 600 series motherboard, like the B850, B650, or X870 series. Now for Ryzen 5000 series CPUs, you generally want an AMD 500 series motherboards, like a B550 chipset motherboard. Intel motherboards are a little bit more complicated. Intel CPUs with a K in the name can be overclocked using a Z series motherboard. The Z series motherboards are Z890 for the Core Ultra 200 series and Z790 and Z690 for Intel's 12th, 13th, and 14th gen CPUs. But you can also use any Intel CPU at stock settings on a compatible B series motherboard. B860 motherboards work for Core Ultra 200, and B660 and B760 work for 12th, 13th, and 14th gen Intel CPUs. In my opinion, B series motherboards are the better and more affordable choice for both Intel and AMD CPUs. Now, motherboards come in 4 main sizes: full size or ATX motherboards, a half size version called a micro ATX or MATX, and an even smaller version with a single PCIe slot called an ITX motherboard. There's also a slightly wider than normal board called an extended ATX or eATX. On the back of the motherboard, there will be USB ports of varying speeds, audio output for the onboard sound, wired and wireless networking, and display outputs if you're not using a dedicated GPU. Now, motherboards also have either 2 or 4 RAM slots, SATA connections for SATA storage drives, and at least 1 slot for M.2 storage drives, as well as connections for the system fans, RGB, and front PC case USB and audio ports. Now the motherboard also has onboard operating system called BIOS. That allows you to change the way that the motherboard, the memory, or other components run. One of the most important motherboard features is the power delivery on the motherboard, called the VRMs. It's a little half square around the CPU, which often has a heatsink to avoid overheating under heavy use. You need to pay close attention to these if you're using an 8-core or greater CPU. There are also PCI Express slots, called PCIe slots. The top one is for the graphics card and is a by 16 slot that refers to the number of PCIe lanes and also refers to the length of the connection. They also vary in size depending on how much bandwidth they have, including by 8, by 4, and by 1 slots. Note that smaller add-in cards can be used in the larger slots. PCIe lanes can go different speeds, and the current fastest ones are PCIe Gen 4 and Gen 5. Currently, even the fastest RTX 5090 graphics cards run just fine on a PCIe Gen 4 motherboard GPU slot. Motherboards also come with built-in audio. If you plug in an analog audio device with a connector into the motherboard or front panel of the PC case, you're using the motherboard audio processing. But if you use a connection like HDMI or USB, then you're going to be using the digital signal to transfer the audio processing to a secondary device like a stereo receiver. Now, the quality of the onboard audio can usually be tracked by looking at the audio codec. Audio codecs in the 800 series, so AL897 for instance, those are entry level, those are fine to get going. If you want better audio, then look for audio codecs like ALC1200 or higher. If you are using a higher end audio codec, make sure to plug in your analog headphones into the front PC case plugs to take advantage of their special features to improve headphone performance. All right, let's talk about RAM, also called memory, because right now we are in a global RAM shortage and it's caused by insane AI data center expansion. While RAM is still available, it does cost quite a bit more than it did last year. Now, RAM is what the system uses to temporarily store information it's using right now. For RAM, there are a couple of important things to know, like how much you need, how fast the RAM is, and whether or not you need to get DDR4 or DDR5 RAM, as we're still in a transition between the two. Now note that we have a whole video on the best RAM for gaming, which goes over all the available CPUs and recommends specific RAM for each of them, as well as explaining how RAM works, so check that out in the How to Build a PC playlist down in the video description. Now, RAM comes in sticks that are called DIMMs, and they're generally bought in kits of either 2 or 4 sticks. You generally want to use RAM sticks in pairs, so avoid a single stick or 3 sticks. And we never recommend mixing and matching different RAM kits. Current RAM comes in either DDR4 or DDR5. The number at the end just denotes the generation. Older Ryzen 5000 series CPUs only use DDR4 RAM, while Ryzen 9000 and 7000 series CPUs only use DDR5 RAM. Intel Core Ultra 200 CPUs only use DDR5 RAM, while Intel 12th, 13th, and 14th generation CPUs can use either one, but not both at the same time. And that choice is locked in when you buy the motherboard, and the board specs will say whether it's a DDR4 or a DDR5 motherboard. Now, most common memory speeds for DDR4 are between 3200 and 3600, and for DDR5 kits from 5600 to 6000 all the way up past 8000, though faster RAM does not always give better performance, and most CPUs have a sweet spot for RAM speed. In order to achieve these speeds, most RAM comes with auto overclocking profiles like XMP or Expo, which you will need to enable in the BIOS in order to get the full rated speed. RAM also has a CAS latency, abbreviated CL or C with a number. Common CAS latencies for DDR4 are CL14, 16, and 18. For DDR5, they range from CL28 to CL40 on mainstream kits. There's also a lot to talk about for the best RAM speeds for each of the CPUs, so check out that best RAM for gaming video linked in the video description. How much RAM do you need in 2026? Well, due to increased RAM prices right now, many gamers are going back to 16 gigabytes of RAM, which is enough for gaming and even many tasks like amateur video level editing. Professional workstation users are probably going to want to get at least 32 gigabytes of RAM, depending on the applications that you use. While RAM prices have increased, 32 gigabyte kits, they're still better priced per gigabyte than 16 gigabyte kits. So going up from a 16 gigabyte kit to 32 gigabyte kit, it's around $100 to $150 rather than double the price of the 16 gigabyte kit. All right, let's move over to storage. We are also in an SSD shortage due to huge AI data center expansion. As a result, SSD prices have increased quite a bit, though not yet to the level that we're seeing with RAM. Now, the most popular storage drives in 2026 are M.2 NVMe SSD drives. They plug directly into an M.2 slot on your motherboard. Now, most motherboards have between 2 and 5 M.2 SSD slots, depending on the motherboard. NVMe SSDs come in a variety of speeds called PCIe generations, which we abbreviate as Gen. Now, for the vast majority of consumers, PCIe Gen 3 and Gen 4 drives are actually faster than you need. The newest Gen 5 drives don't offer consumers any real benefit. They're often quite a bit more expensive than PCIe Gen 3 or Gen 4 drives, and only the latest CPUs and motherboards will run them at their full rated speed. Now, my advice, skip PCIe Gen 5 drives. Get a nice PCIe Gen 3 or Gen 4 one instead. Do note that PCIe is backwards compatible, so you can't always plug in a PCIe Gen 3 drive into a motherboard with a PCIe Gen 4 or even Gen 5 slot. It's just going to run at the slower rated speed. That's still really fast. Now, alternatively, if you plug in a Gen 5 NVMe SSD drive to a motherboard slot that only supports like PCIe Gen 3, for instance, it will run, but only at the slower Gen 3 speed. Also note that for most users, a single high capacity drive, it runs just as fast as multiple single drives, and it's often cheaper. So rather than getting two 1 terabyte drives, get a single 2 terabyte drive to save money. While you still can't buy SATA hard drives or SATA SSDs that run off of a SATA cable, there's no cost savings right now for SATA SSDs, and hard drives are just too slow for most consumer users. But if you have an older drive that you want to bring along to your new build, newer motherboards still have SATA ports to connect them. CPU coolers make sure that your CPU doesn't overheat and throttle your performance, because that's bad. Generally, the more cores a CPU has, the more power it requires. And I'm looking at you, Intel i9-14900K, and the more cooling it will require. Now, you can do that with an air cooler, an all-in-one liquid cooler, also called an AIO, or with a custom-built liquid loop cooler. Now, if this is your first PC build, or your first PC build in a while, I recommend skipping a custom loop cooler. Go straight for either an air cooler or an all-in-one liquid cooler. Note that some Ryzen and Intel CPUs come with an included box cooler. Those are usually fine for more budget builds. For most Intel CPUs, other than the lower-end Core Ultra 5 225 and the i5 12400, I do recommend upgrading at least to a budget tower air cooler. And most AMD CPUs no longer come with an included stock cooler, so you will need to pick one up. We have more cooling guides in our How to Build a PC playlist, and we recommend specific coolers for each CPU in our build guide list. So check those out, linked down in the video description. All right, let's talk PC cases and fans and some customization here. Your PC case has 3 jobs. Keep your PC parts safe, get your PC parts airflow to keep them from thermally throttling, and of course, look amazing. For airflow, it's important to bring in cool air from the outside and vent out the hot air from the inside to avoid thermally throttling. Now, for this, mesh front or side panels are best. We can buy additional fans and often need to. PC cases usually come with at least a couple of included fans in the 120mm and 140mm size, though there are some cases with much larger 160mm and even 200mm fans. Notice that the larger the fan, the slower it needs to spin to bring in the same amount of airflow, and the quieter it can be, though some fans are noisier than others even when spinning at the same speed. How many fans do you need? I recommend at least 2 to 3 intake fans as well as at least 1 exhaust. In high-end builds with more heat, I would recommend increasing this airflow. Now, slightly biasing our fans to intake also allows us to create positive pressure in the PC case and allows us to control the amount of dust getting into the case. Now, of course, we want to make sure that you buy the right size PC case for your motherboard. Like motherboards, cases come in different sizes. ATX cases will fit ATX size and smaller motherboards, but micro ATX cases will not fit an ATX full-size motherboard, and many small form factor cases will only fit ITX motherboards. If you're not sure, check the PC case specs before you buy to make sure it's going to fit your motherboard. And of course, let's talk aesthetics and front panel connections. Now, most cases come with a glass side panel to show off your build, and the front panel of your case will include USB ports and an audio jack. If it's got a front panel USB Type-C connector, you'll want to ensure that your motherboard comes with the right header for it. Now, some cases come with RGB lighting effects or strips, but most RGB lighting today is on the fans, the coolers, RAM, and motherboards themselves. Now, the power supply unit, or PSU for short, supplies power to your PC build. However, choosing the right PSU, it's complicated. But don't worry, we've got a whole video that explains how to size, evaluate, and buy the best PSU, included in our How to Build a PC series. PSUs come in 2 main sizes: ATX, which is the size that's most common, and SFX, which is for small form factor cases. Now, make sure to choose a PSU that fits your case. PSUs come in different wattages. They also have different efficiency ratings called 80 plus ratings in either white, bronze, gold, or platinum, but these 80 plus ratings don't necessarily indicate the unit's quality. Instead, we look at a rating system put together by knowledgeable community members called the SPL PSU tier list. For a gaming build with a dedicated GPU, we recommend using a PSU that's rated at least C tier or better on that list. As the performance and cost of your CPU and GPU go up, we suggest moving up the tier list to B tiers and then A tier. You can think of this a little bit like buying car insurance. The more expensive your car is, the more insurance coverage you're going to want, even though you're paying more money for that insurance. Again, check out our full PSU buying guide linked down in the video description before making your purchase. All right, so how much do you need to spend on your PC build in 2026? Now, I'm doing this towards the beginning of the year, and with the increases in RAM and SSD prices starting in late 2025, builds are more expensive now and in the foreseeable future. But one resource to consider is your local PC parts retailers who are comboing parts together for really good savings. Newegg in particular in the US is offering incredible RAM and motherboard combos, often with CPUs or other components, offering significant savings on the RAM or SSDs. Micro Center in the US also offers these, but they're in-store only, so check it out if you have a store near you. And if you're not in the US, check out your local PC parts retailer to see what kind of deals that they're offering. Despite higher RAM and SSD prices, you can build a gaming PC right now for less than $800 US with all new parts, capable of playing many games at 1080p high settings or 1440p medium settings. And that's without using any combo deals. Now, this build uses a more budget CPU in the Ryzen 5500, which comes with a perfectly good included CPU cooler. We pair it with an Intel Arc B570 10GB GPU, along with a very solid B550 Micro ATX motherboard, 16GB of DDR4 RAM, a 1TB budget NVMe SSD, a cheaper but very good PC case with 3 included ARGB fans, and a C-tier rated PSU. If we use one of the Newegg combo deals with a motherboard, 1TB SSD, and a different 16GB kit of RAM with RGB, it brings down the cost to under $680. And I'll leave links to these directly in the video description. Now, we can upgrade the GPU on our $800 build to an even faster Arc B580 12GB for about another $50, or go even faster with an RX 96XT 16GB GPU for about $200 more. So just about $1,000 total build costs. And we could also look at dropping in a faster Ryzen 5600 CPU as well for a build of around $1,050. Now, for just about $1,400 US, we can put together a very high FPS 1440p gaming PC build or even a 4K gaming PC build. Using any of the AM5 Ryzen CPUs, I've gone here with the Ryzen 7500F for $159 with an included stock cooler, a value-oriented B650 Micro ATX motherboard, 16GB DDR5 kit, RX 9070 16GB GPU for about $630, a 1TB budget SSD, an Atrium-style Micro ATX PC case, and a C-tier 600-watt PSU. Now, using a really good Newegg combo available right now for $440, the build cost comes down about $100. And now we have a slightly faster Ryzen 7600X CPU, we pick up a 240mm all-in-one liquid cooler, and we add RGB to the RAM. And of course, this would be great with an RX 9070 XT, RTX 5070, 5070 Ti, or even a 5080 as well. For very high FPS gaming at 4K or insane 1440p frame rates, we can do a build around $2,000. We're going to go with a very fast Ryzen 7800X 3D CPU, a dual tower air cooler, a premium B850 motherboard, 32GB of DDR5 RAM with RGB, an RX 9070 XT 16GB graphics card, 1TB NVMe SSD, a very nice Atrium-style ATX-sized PC case by Lian Li, like this one here, and an A-tier rated 850-watt power supply. Now, using one of the better Newegg combos right now, we can actually do this build for under $2,000 while upgrading our CPU to the fastest Ryzen 9850X3D, upgrading the motherboard to an X870, which comes with the RAM kit. Of course, pricing in 2026, it's somewhat volatile. I do expect prices to creep up over time given the current shortages, but these builds should give you an idea of what you can do in 2026. And I'm going to link all of them down in the video description, along with links to the combo deals at Newegg. I'm also going to link our How to Build a PC 2026 playlist. That has videos on each component, as well as how to actually build your PC and set it up after you build. I'm also going to link our PC build list playlist that has different CPU-based build guides and our monthly best builds at different price points. Of course, if you got value out of this video, please give it a like. It makes a huge difference to the channel, and subscribe for more cool PC content like our best gaming monitor 2026 video, which you can check out right here to pick up your next gaming monitor and get a great deal. Check it out, and we'll catch you on the next one.